Hello everyone, my name is Pawan Malwal and today I'm gonna give you a brief introduction of Apache Spark. So Apache Spark is a unified analytics engine for large-scale data processing. Spark is a next-generation real-time and batch processing framework. It was developed at UC Berkeley in 2010. The project was donated to the Apache Software Foundation and it became an Apache top-level project in 2014. In November 2014, Databricks made a new world record in large-scale sorting using Apache Spark. Let's have a look at its features which makes it a most popular processing engine. So Spark enables applications in Hadoop cluster to run up to 100 times faster in memory and 10 times faster even when running on disk. Unlike Hadoop, Spark maintains the intermediate results in memory rather than writing every intermediate output to disk. This enormously cuts down the execution time of the operation, resulting in faster execution of tasks as more as 100x times a standard MapReduce job. Apache Spark can also hold data on the disk. When data crosses the threshold of memory storage, it is spilled to the disk. This way, Spark acts as an extension of MapReduce. Spark doesn't execute the task immediately but maintains a chain of operations as metadata of the job called DAG. The action on the DAG happens only when the action operation is called onto the transformation DAG. This process is called as lazy evaluation. So its second feature is ease of use. So Spark offers over 80 high-level operators that make it easy to build parallel apps, and you can use it interactively from the Scala, Python, R, and SQL shell. Third one is generality. So Spark powers a stack of libraries including SQL and data frames, mlib for machine learning, GraphX, and Spark streaming. You can combine these libraries seamlessly in these applications. Fourth one is runs everywhere. So Spark runs on Hadoop, Apache Mesos, Kubernetes standalone, or in the cloud. It can access diverse data sources. You can run Spark using standalone cluster mode on EC2, on Hadoop Yarn, on Mesos, or on Kubernetes. Access data in HDFS, Apache Cassandra, Apache HBase, Apache Hive, or hundreds of other data sources. Now let's understand what batch and the real-time processing means. In typical cases, batch processing is used to execute multiple operations. It handles heavy data loads, generate reports, and manage data workflow, which is offline, and examples is to create daily or hourly reports to aid decision making. On the other hand, real-time processing occurs instantaneously on data entry or command receipt. It needs to execute within strict response times. Constraint, as example, is the fraud detection, which we should do in a limited time constraint. Okay, so the need of the Spark was created by the limitations of MapReduce, which is another data processing framework in Hadoop. Let's see what these limitations are. MapReduce is suitable for batch processing where data is processed as a periodic job. That is the reason it takes time to process data and provide results. If the data is high depending on the amount of the data and the number of nodes in the cluster to complete a job, it takes minutes to process the data. However, it is not a good choice for real-time processing. MapReduce is also not suitable for writing trivial operations such as filter and join. To write such operations, you might need a rewrite the jobs using the MapReduce framework, which becomes complex because of the key value pattern. This pattern is required to be followed in reducer and mapper code. MapReduce doesn't work well with large data set on the network because it takes a lot of bandwidth and time to copy the data, which may cause network issues. MapReduce works on the data locality principle and hence works well on the node where the data resides. And MapReduce is also unsuitable for online transaction processing or OLTP, which includes a large number of short transactions. Since it works on the batch oriented framework, it lacks latency of seconds on sub-seconds. Additionally, MapReduce does not support graph processing as well. And MapReduce is a stateless and not suitable for iterative programs execution like k-mean algorithm need that data need to be processed multiple times to refine results. So Spark is an open source cluster computing framework which addresses all of the limitations of MapReduce. It is suitable for real-time processing operations and processing larger data on a network. It is also suitable for OLTP graphs and iterative executions. Spark provides up to 100 times faster performance for a few applications within memory primitive compared to the disk-based MapReduce jobs of Hadoop. And the Spark's fast performance makes it suitable for machine learning algorithms as it allows program to load data into the memory of a cluster. Now let's have a look at the Spark architecture. Spark comprises various components such as Spark Core, RDDs, Spark SQL, Spark Streaming, Machine Learning or MLlib or GraphX. Let's discuss each of its component in detail. The first component Spark, Core and RDDs are the foundation of entire Spark project. They provide basic input or output functionalities, distributed tasks, and dispatching and scheduling. RDDs are the basic programming abstraction and it is a collection of data that is partitioned across machines. Logically, RDDs can be created by applying transformations on the existing RDDs or by referring external databases. The example of these transformations are reduce, join, filter, and map. The second component is Spark SQL, which resides on top of the Spark core. It introduces Spark RDDs and Schema RDDs, which is a new data abstraction and supports semi-structured and structured data. By the Spark SQL also supports SQL with Open Database Connectivity or Java Database Connectivity, commonly known as ODBC or JDBC server, and command line interface. Third component is Spark Streaming. Spark Streaming leverages the fast scheduling capabilities of Spark Core for streaming analytics, ingesting data in small batches, and performing RDDs transformation on them. The fourth component of Spark is Machine Learning Library, also known as MLlib. It lies on top of the Spark and is distributed machine learning framework. MLlib applies various common statistical and machine learning algorithms with its memory-based architecture. And the last component, GraphX, which also lies on the top of Spark and it is distributed graph processing framework for the computation of graphs. So the Spark provides up to 100 times faster performance for a few applications within memory primitives. It provides faster data access for end users within memory processing. It is possible to access visually rich data boards and existing data sources. Spark is chosen over MapReduce mainly for its performance advantages and versatility. Apart from these, another critical advantages is its development experience along with the language flexibilities. And Spark provides support to various development languages like Java, Scala, Python. So this was the brief introduction of Spark. Thank you so much for watching this video. For now, bye bye.